Hi everyone, welcome once more to this channel, Best Science Brain YouTube channel. So at this hour, we're presenting solution to NECO July 2024 chemistry theory. So we're going to provide solution to this theory and then correct explanation to the questions. So at the end of the video, you also watch the video to the end, and then you're going to have the objective question also coming after this video, and the explanation and also the solution. So let's start once. So part 2 is the answer 4 questions only. So we're going to provide solution for 5 questions, but you're going to select only 4. 5 questions here, you select 4. So question 1A says state 3 physical properties of hydrogen. Solution: odorless and colorless gas, number 1. 2. Less dense than air. 3. Boils at minus 252.87 degrees Celsius. Number 4, slightly soluble in water. So you select any 3. 1B says, given the elements fluorine, iodine, chlorine, and bromine, I name the group to which they belong in the periodic table. Solution: they belong to group 7, VII. That V and the I will be written in capital letter. Don't write group 7, VII, Roman number. V capital, I capital, no dot on them, please. Then 1BII says, which of them is the least reactive? Solution: iodine, the least reactive among the 4 mentioned. 1B says, which of them is solid at room temperature? Solution: the same, iodine is solid at room temperature. We now go to 1CI. Name 2 cations that can cause hardness. 2 cations that can cause hardness. Solution: calcium ion, magnesium ion. You don't need to say calcium 2 ion. You don't need to say magnesium 2 ion because these elements have fixed oxidation state. So just say calcium ion and magnesium ion. Write the name, means give the name. Don't write formula. 1CII says, give 2 methods of removal of permanent hardness. Give 2 methods of removal of permanent hardness. Solution: addition of washing soda, that 1, and then number 2, use of cation exchange or zeolite process. You can say distillation process and that method, or addition of caustic soda. These are also other methods. 1DI says state the acid-base titration that uses the following indicators. Methyl orange. Solution: strong acid against weak alkali. Strong acid against weak alkali. You can see that we cancelled strong acid against strong alkali because strong acid against strong alkali can use any indicator, but they are being specific here. We're talking about methyl orange only, so methyl orange is used for strong acid against weak alkali. So phenolphthalein, solution, that phenolphthalein, weak acid against strong alkali. Weak acid against strong alkali. 1DII says, give 1 example each of the following salts. Hydrated. Solution: sodium tetraoxosulfate 6 heptahydrate. Sodium tetraoxosulfate 6 heptahydrate. You can as well say copper 2 tetraoxosulfate 6 pentahydrate. You can as well say sodium triosocarbonate 4 deca, DECA, decahydrate. Any of them is okay. Then acidic salt, we have sodium hydrogen triosocarbonate 4. Sodium hydrogen triosocarbonate 4. You can as well say sodium hydrogen tetraoxosulfate 6. Sodium hydrogen tetraoxosulfate 6. Then basic salt, zinc hydroxide chloride. Zinc hydroxide chloride is the basic salt. 1EI says, arrange the following isomers in increasing or in decreasing order of boiling points. We have 2-methylbutane, pentane, and 2,2-dimethylpropane. 2-methylbutane, pentane, and 2,2-dimethylpropane. So we're going to arrange them in decreasing order, that from the highest to the lowest boiling point. So solution, pentane comes first, greater than 2-methylbutane, which is greater than 2,2-dimethylpropane. So the 2,2-dimethylpropane had the lowest boiling point because it has many branches in it and has very weak van der Waals forces in it. So I repeat, pentane first, greater than 2-methylbutane. Look at the sign, it's greater than, not less than. Then greater than 2,2-dimethylpropane. Move to the next question. EII says, write the IUPAC name of the following compounds. I see the first compound there. I look at it very well. The IUPAC name of that compound is 1-bromo, 1-bromo, and that hyphen, 2-methylbutane. Look at methyl and butane. The two words are joined together, no spacing. So look at the word very well. No error in it. Then II, you have the structure there. The IUPAC name is 3-methyl-pentan-2-or. 3-methyl-pentan-2-or. Repeat. 3-methyl, no gap after from between methyl and pentan, that together. 3-methyl-pentan-2-or, OL. So look at that naming. After the 3, there is hyphen. The methyl and pentan are joined together. It's one word. Then after the pentan, hyphen, 2, and that hyphen, and then or you can name it like this. You can still call it 3-methyl, hyphen, 2, hyphen again, then pentanol. So any of these names will give you accurate score. Then EII says, state one use of benzene. Solution, any of them is okay. Production of stearine or phenylbenzene, that's the IUPAC name. So benzene is produced stearine, or what called polystyrene. Then also used to manufacture of detergents, dyes, and pharmaceuticals. So the first used to produce stearine or polystyrene, which you can call polyphenylbenzene. Then you can use manufacture detergents, dyes, and pharmaceuticals. So any one use will score. 1EIV say define saponification. Solution, it is the alkaline hydrolysis of fats and oil to produce soap and propane hyphen 1, 2, 3 hyphen triol, TRIOL. Is alkaline hydrolysis. I say alkaline, INE, alkaline hydrolysis of fats and oil to produce soap and propane hyphen 1, 2, 3, and that hyphen triol. Go to 1F that says a chloride of element S has the formula SCl4 and a vapor density of 77. Calculate the relative atom mass of S. So chlorine atom mass is at 5.5. Solution, we have that solution there. RMM equal to 2 times VD. RMM means relative molecular mass and VD vapor density, that relationship. So combine the density to molecular mass, which is going to be 2 times 77, that gives us 154. We now have LCl4 equal to 154. We substitute chlorine with 5.5, that is S plus 4 times 5.5 equal to 154. Then making L the subject, L becomes 154 minus 142, and that will give you 12.0. So the mass of S is 12.0, and S is definitely carbon. We go to number 2, having done justice to number 1. Number 2 says 2a. What's the molar solution? We say solution, a molar solution. This is a standard solution. This is a standard solution which contains 1 mole or the molar mass of a compound in 1 dN cube, bracket opens, or you say 1000 cN cube of water. I repeat, this is a standard solution which contains 1 mole or the molar mass of a compound in 1 dN cube or 1000 cN cube of water. 2AII says calculate mass of sodium carbonate in 250 cN cube of 0.10 mole per dN cube solution, and the molar mass of sodium carbonate given to you in bracket as 106 gram per mole. Solution will apply the concept mass over molar mass equal to CV over 1000. Both formulas are equal to number of moles. We now make mass the subject. Mass now becomes CV times molar mass over 1000. We make a substitution with the values given to us. Mass becomes 0.1, that's the concentration, times 250, the volume, times the molar mass 106 over 1000. That 1000 there is to convert this 250 there to dN cube. So when we solve, the answer is 2.65 grams to 3 SF. 2BI says, what do the following values of a Brune constant K indicate in a reversible reaction, reversible chemical reaction? So let's go to the values. Question I, K being greater than 1, what does it indicate? Solution, it means that the concentration of the products is higher than the reactants. That the concentration of the products is higher than the concentration of the reactants. So, full stop. That means for reaction is favored. For reaction is favored. So when K is more than 1, it means that the concentration of the products is higher or greater than those of the reactants. Full stop. And also, for reaction is favored. Question II. When the value of K is less than 1, solution, it means that the concentration of the reactants is higher or greater than that of the product. Full stop. That means reverse reaction is favored. Going to II part of it, when K is equal to 1, solution, it means that the concentration of the products equals that concentration of the reactants. So concentration of the products equals concentration of the reactants. That's what it means when the Brune constant K is equal to 1. Then 2BII says, state 3 factors that affect a system in equilibrium. Solution, temperature, pressure, concentration. Please, catalyst is not there. Temperature, pressure, and concentration according to Chatelain's principle. Chatelain's principle. When I go to 2CI, says give 2 differences between strong acid and weak acid. Solution, we have the solution in the form of a table. Strong acid, number 1, ionizes completely in aqueous solution. Weak acid ionizes partially in aqueous solution. Then number 2, for strong acid, produces a low pH value in aqueous solution. For weak acid, produces a higher pH value in aqueous solution. Then the third one, for strong acid, conducts large amount of electricity in solution, while for weak acid, conduct less amount of electricity in solution. So you choose any 2 differences. Number 2CII says, mention 3 properties of covalent compounds. Solution, 1, low boiling and melting points. 2, consists of molecules and or lack ions, that is stroke, that means or. So consists of molecules or lack ions. Then 3, non-polar and do not conduct electricity. So these are the properties of covalent molecules or compounds. Then 2DI says, write the possible structural isomers of chlorobutane. Solution, you draw them, and when you draw each one, you name it. Look at the first structure. Look at it very well. So 4 carbon, single bonds, all true. Then on the with hydrogen all through except the first carbon, the carbon on the right hand side that has one chlorine atom beneath it. So this is called 1-chlorobutane, 1-chlorobutane. Chloro and butane are joined together as one word. The next one, or let's go to this side. The next one, you see, the chlorine have been shifted from number 1 carbon on the right hand side to the second carbon. You can see it, the difference. So 2-chlorobutane, second structure. The third structure, you have only 3 carbon on the straight chain. Then the carbon on the left-hand side, on the right-hand side, the first carbon is carrying chlorine. The second carbon is carrying CH3, the methyl group. Every other carbon is carrying hydrogen. This is called 1-2-methylpropane. Methyl and propane, the names are joined together. Then the third one, you can see that. So this one has chlorine and the methyl group CH3 line on the middle carbon. You can see very well. So this is called 2-chloro-2-methylpropane. That propane written on that should be behind. That propane should come immediately after methyl and they be joined together. Methyl and propane should be joined together as one word. So there's no space, that will have to write it down. 2-DII says, name the monosaccharides contained in sucrose. Solution, glucose and fructose. Glucose and fructose are the monosaccharide contained in sucrose. Then 2-DIII says, mention 2 factors responsible for protein denaturation. 2 factors that cause protein denaturation. Solution, high temperature, then extreme pH levels, either too acidic or too alkaline. High temperature, extreme pH levels, either too acidic or too alkaline. You don't just say temperature, you must say high temperature and then extreme pH levels. Number 3, we'll go to number 3 question that says, write the chemical equations to show the stages involved in the manufacture of tetrophosic acid by contact process. Solution, the first equation is solve for S plus O2, giving us SO2. Second equation is 2SO2 plus O2, and you have a reversible sign, and then on top of that sign is the catalyst V2O5. V capital O capital vanadium 5 oxide V2O5, giving us 2SO3. The third equation, SO3 plus H2SO4, will give us H2S2O7. H2S2O7. Then the fourth equation, H2S2O7 plus water will give us 2H2SO4. 2H2SO4. Mind you that the second equation bear reversible sign and the catalyst on top of it. 4 equations here. 3-AII says, mention 3 factors that are responsible for the feasibility of a reaction. Solution, gives free energy, number 1. Number 2, heat of reaction or the enthalpy change. Number 3, change in entropy. 3-AII says, state 3 factors that determine the preferential discharge of ions during electrolysis. Solution, position of ions in the activity series, or you can say electrochemical series. Number 2, conserve ions in this electrolyte. Number 3, nature of electrodes. So you can see very well. So we're gonna go to 3B. It says 0.75 mole per dm cube of magnesium sulfate .S water, whose concentration in gram per dm cube is 184.5. Calculate the value of S in MgSO4.S water. Solution, molar mass, that's mm, equal to concentration in gram per dm cube all over conc in mole per dm cube. Substituting, that is going to give us 184.5 all over 0.75. That gives us 246 gram per mole at the molar mass. We now equate MgSO4.S water to equal to 246. Substitute. The mass of Mg is 24 plus 32 for sulfur plus 16 times 4 for oxygen plus S times 18, the molar mass of water. Replace the dot with plus equal to 246. They will add up and make S the subject. So we have 18S equal to 246 minus 120. The 120 is the sum of 24, 32, and then 64. That gives you 120. So 18S equal to 246 minus 120, and that will give us 126. So make S the subject. S becomes 126 over 18, and that will give us 7. So S is 7. Number 3 CI says, define reduction in terms of oxidation number. Solution, it is the decrease in oxidation number. I repeat, define reduction in terms of oxidation number. Solution is the decrease in oxidation number of a substance from the reactant to the product side during a redox reaction. Decrease in oxidation number of a substance from the reactant to the product side during a redox reaction. So 3CII says, identify the oxidant agent in this reaction. We have H2S plus bromine giving us 2HBr plus sulfur. So oxidant agent there is bromine, BrO2. That's the agent there. So 3CII says, state 3 features of organic compounds. Solution, low melting and boiling points. Number 1. Number 2, mostly nonpolar, except those whose molecules can form hydrogen bonds. Example, alkanols. That's number 2. Number 3, highly inflammable. Number 3, reactions are slow and require heating and a catalyst. So any 3 of these is okay. Low melting point and boiling point, mostly nonpolar except those whose molecules can form hydrogen bonds, e.g. alkanols. Highly inflammable, reactions are slow and require the use of catalysts or heating. So that is it. So 3CIV leads to sources of fats and oil. So we know that fats and oil normally come from animals. So you cannot just say animal and plants, but they say these 2 sources of plants and animals. So let's see. So let's go through the question once more. It says lead to sources of fats and oils. So normally we have butter and margarine from plants, coconut and palm oil from plants also, then meat in bracket beef from animals. So these are the sources. So choose one from plants and choose one from animals. Number 4A says, we'll not go to number 4 now. What is allotropy? It is solution, the existence of an element in 2 or more forms in the same physical state with similar chemical properties but different physical properties. 4AI says, give one example of element that exhibit allotropy. So we have solution oxygen, sulfur, and carbon. Anyone scores. Oxygen, sulfur, and or carbon. Anyone is what you're going to write. So for AII, say to use of carbon 4 oxide. Solution, used in fire extinguisher, to use in the industrial production of sodium carbonate in bracket washing soda and sodium hydrogen carbonate in bracket baking soda. So that is it. We go to the next question. Write a unique form of a group 3 element. So I need from a group 3 element. Solution, we can say S, and the charge is 3 plus. So that S represents our elements. So all group 3 elements have 3 plus at their charge. So that's the way of writing it. So you can say use M, then 3 plus, capital M to represent the element. So but 3 plus will be there. Then 4BII says calculate the mass in grams of oxygen required to burn 4.8 grams of calcium To solve this problem, we have to write the equation between calcium and oxygen. We have 2 moles of calcium plus 1 mole of oxygen. So 2Ca plus O2 giving us 2CaO. We now go to from the stoichiometry, 2 moles of calcium, write it with 1 mole of oxygen. And the atomic of calcium is 40. We now say 2 times 40. Then oxygen molar mass is now 16 times 2 because of 2 atoms there of oxygen. So that now give us down 80 grams of calcium, giving us 2 grams of oxygen. Therefore, 4.8 grams of calcium will now give us 4.8 times 32 over 80. And that will give us 1.92 grams of oxygen as our answer. 1.92 grams of oxygen. 4Ci. When steam is passed over red hot iron filings, the products formed are oxide S and gas Y. Question 1, identify S and Y. S is iron 2 bracket II, and iron 2 is one compound, iron 2 iron 3 oxide. The Roman numbers are in capital letter. Please, it is not iron 2 iron 3, no. Iron 2 iron 3 oxide. The Roman numbers in bracket are in capital letters. Then Y is hydrogen gas. The number II says write an equation for the reaction in Ci above. So you have 3 moles of iron, then solid in bracket, plus the S is solid, plus 4 molecules of water or steam. So G in bracket, reversible sign there, giving us the iron 2 iron 3, that's Fe3O4 solid plus 4H2 gas. So that's the balance equation for the reaction. So II says what the color formed when potassium iodide solution is added to lead-2 salt. What the color formed when potassium iodide solution is added to lead-2 salt. Solution yellow. Solution yellow. When I go to 4Cii, it says sketch a graph to illustrate Boyle's law. Graph to illustrate Boyle's law. In the graph of Boyle's law, we plot pressure again on the vertical axis against 1 over V on the horizontal axis. You draw a straight line from origin straight up and then put 0 at the origin. So this is the graph of Boyle's law. Now, for the II says, why is nitrogen prepared from air denser than pure nitrogen? Solution: nitrogen prepared from air contains noble gases, which increases its density. Nitrogen prepared from air contains noble gases, which increases its density. For the II says, calculate percentage composition of sodium in sodium nitrate. Solution: we find the molar mass of nitrate, mm of NaO3 gives you 23 plus 14 plus 16 multiplied by 3. That gives us 85.0 grams per mole. Then mass of 1 atom of sodium is 23 grams, since there's only 1 atom of sodium there. So percentage of sodium becomes mass of sodium all over molar mass of NaNO3 times 100 over 1. That gives us 23 over 85 times 100 over 1. And that will give us approximately 27.1% to 3SF. 27.1%. For D-III says, classify the following into heavy and fine chemicals: ammonia, dross, and sodium hydroxide. Solution: fine chemicals, the only fine chemical there is drug. The heavy chemicals are ammonia and sodium hydroxide. So go to number 5. We have that equation, ammonium chloride decomposing into A plus B. From the equation, we ask, name the product A and B. So solution: A is ammonia, and then B is hydrogen chloride gas. A is ammonia, B hydrogen chloride gas. Then II says, mention the type of chemical reaction the equation represents. Solution: thermal dissociation reaction. Solution: thermal dissociation reaction. Then 5AII triple I says list 3 types of chemical bonds. Solution: ionic or electrovalent bonds, covalent bonds, coordinate covalent bonds, metallic bonds. Any 3 is okay from these 4 listed. Number 5, BI. Give 2 compounds that can be used to identify the presence of water. Solution: anhydrous copper 2 6, and then anhydrous cobalt 2 chloride. You must mention anhydrous there, please. Then 5BII. State 3 precautions that should be taken in order to have accurate burette reading during titration. Solution: 1. Burette should be rinsed. That should be past tense. Please put D after the E. Should be rinsed with some volume of acid it is meant to contain. The burette should be rinsed with some volume of acid it meant to contain. 2. The tap of the burette should not be leaking. 3. Readings should be taken at eye level to avoid or prevent errors due to parallels. So you see the precautions. So go to the next question. 5C. Explain the following periodic properties across the period and down the group. I, atomic radius. I, ionization energy. Solution: I, atomic radius is 1/2 the distance between the nuclei of 2 covalently bonded atoms in a molecule. It decreases across a period due to increase in effective nuclear charge. It decreases across a period due to increase in effective nuclear charge and increases within a group due to increase in shielding effect. We go to ionization energy. II. Ionization energy is the minimum energy required to remove a valence electron from a neutral atom in its gaseous state. It increases across the period due to increase in effective nuclear charge and decreases within a group due to increase in shielding effect as the valence electrons are screened from nuclear attraction. Okay, next question. 5CII says, draw the electronic configuration of the following elements using the SPDF notation. I, potassium, II, magnesium, III, oxygen. So you're going to first of all write their EC first. Potassium 19. The numbers given in bracket are wrong in the question. The numbers they give is the mass number. That is an error. Use the atomic number to write EC. Potassium is 19. 1s2, 2s2, 2p6, 2s, 3s2, 3p6, and then 4s1. You draw the beta diagrams. 1s will have the 2 unpaired electrons inside it. 2s, 2 unpaired electron, 1s, 2 electrons in opposite direction, 2s, 2 electrons also in opposite direction, 2ps, py, pz, containing also 2 electrons all in opposite direction, 3s, 2 electrons in opposite direction, 3ps, py, pz, 2 electrons in opposite direction, and then the last one that should come after is 4s that contains only 1 electron pointing up. So that is potassium for you. Then for magnesium, the EC is 1s2, 2s2, 2p6, 3s2. They draw the buses. 1s, 2 electrons in opposite direction, 2s, 2 electrons in opposite direction, 2ps, py, pz contained in 1 bus, but partitioned. 2 electrons in opposite direction, 3s, 2 electrons in opposite direction. So this is for magnesium. Go to oxygen number 8. The EC is 1s2, 2s2, 2p4, 1s, 2 electrons in opposite direction, 2s, 2 electrons in opposite direction, then 2p partition into 2ps, py and pz. Only ps has 2 electrons in opposite direction, while py and pz contain only 1 electron pointing upwards. File D says Di. Mention the ions present in acidified water. Solution: hydrogen ion, hydroxide ion, and then tetrosopher ion. So there are 3 ions there: hydrogen ion, hydroxide ion, and tetrosopher ion. Then 5DII. What's the physical change? Solution: a physical change is a change in which no new substance is formed and it is easily or it is reversible. A change in which no new substance is formed and it is reversible. So you stay connected while we bring your objective questions, objective soonest. Okay.